Hello, and in this video we'll take a look at A-level physics, specifically for EDEXCEL. We'll take a look at the wave model, photon model, and also the photon energy equation in this video. So specification point 90 states that we need to understand how the behavior of electromagnetic radiation can be described in terms of a wave model and a photon model, and how these models developed over time. Specification point 91 states that we need to be able to use the equation E equals hf that relates the photon energy to the wave frequency. And specification point 92 states that we need to understand that the absorption of a photon can result in the emission of a photoelectron. Now, considering the wave theory of light, we know that light is very unique, as not only can it behave as a wave, but also as a particle, and this phenomenon is known as wave-particle duality. Now, light is an electromagnetic wave that oscillates with perpendicular vector components, and these components are known as electric and magnetic fields. The wave oscillation also occurs with a velocity v that is perpendicular to both these vector fields. So taking a look at the following animation on the right hand side, we see that there is a red wave oscillating vertically, and that represents our electric fields. And perpendicular to that electric field, there's a following blue wave oscillating, and that is basically our magnetic field. So these two components, or vector components, oscillate perpendicular to each other, and this entire wave moves with a velocity v that is perpendicular to both of those vector components. Now, just like mechanical waves that carry energy, light waves carry energy which is stored in the electric and magnetic fields. Now, experiments which validate the wave theory of light are both the single and double slit experiment, which uses light of a monochromatic frequency that spreads past the aperture or apertures, causing a series of bright and dark fringes which are a result of constructive and destructive interference. Moving on, we're going to take a look at the particle theory of light, which is also referred to as the quantum theory of light. And in this theory, light carries energy in discrete packets called photons, and the energy carried by each photon is dependent on the frequency of radiation. So the higher the frequency, the greater the photon energy. So here we have a light wave represented by the following green circles. And each of those green circles is an individual photon which consists of a specific energy that is equal to hf, with h being Planck's constant, which has a value of 6.63 times 10 to the negative 34 joules per second, and f being the frequency of that wave. So the photon energy can be represented mathematically as E equals hf. Now, it's important to note that two experiments which validated the photon model of light were the photoelectric effect and also the Compton effect. So the photoelectric effect states that light of a high frequency is shone onto a metal surface, usually UV light, which is absorbed by free electrons present on that surface, and if those electrons absorb enough energy, the bonds holding it to the metal break and they are released, and this is referred to as the photoelectric effect. So the electrons emitted are also referred to as photoelectrons. Now, moving on to take a look at the Compton effect, Arthur H. Compton conducted an experiment in 1923. And this experiment involved the observation of electromagnetic scattering, which involved X-rays that were directed at a carbon target. And basically, different wavelengths of scattered and incident radiation were produced. So, photons are basically a stream of particles which carry energy, and some of that energy and momentum is transferred to loosely bound electrons within that carbon target. And scattered radiation ended up having a higher wavelength than the incident radiation, and this is due to E equals hf and lambda equals c over f. Since the scattered photon has less energy, there is a decrease in frequency, and if there's a decrease in frequency, that therefore must mean that there is an increase in wavelength. Thank you all for watching. I hope this video has made sense and cleared any questions anyone's had regarding wave model, photon model, and also the photon energy equation. Thank you all for watching, and goodbye.